your problem solver! I came here to save you from your life with continuity.
Continuity at a point. We can say that a function f is continuous if and only if the limit of f of x as x approaches a is equal to the value of f of a. So, to determine whether the function f is continuous, it should satisfy these three conditions. First, the value of f of a exists. Next is that the limit of f of x as x approaches a also exists. And then the last is that the limit of f of x as x approaches a is equal to the value of f of a. Well, otherwise, if it doesn't satisfy the three conditions, we can say that the function is discontinuous. And there are two types of discontinuity. So let's proceed to the first one. Essential discontinuity happens when one or both of our one-sided limit does not exist. Next is the removable discontinuity. It happens when the limit of the function exists but does not equal to the value of the function at that point. To make it clear, here are some examples about continuity. But let's proceed first to the sample graphs. We're about to determine whether the given graph is continuous or discontinuous. Example number 1. In this graph, the value of f of a exists, which means the condition number 1 has been satisfied, and it also has limits on both sides, which only means that this graph is continuous. Example number 2. We can see that it only has one-sided limit, which only means that the second condition is not satisfied by this graph, which means that this graph is an essential type of discontinuity. Third example. So this graph contains or has limits on both sides, but the point is hollow, which means that the value of f of a does not exist, or the limit of f of x as x approaches a is not equal to the value of f of a, which means that this graph is a removable type of discontinuity. Let's proceed to the examples that involve solving. Number 1. F of x is equal to x plus 2, x is less than 0, negative 1 when x is equal to 0, 2 minus x squared when x is greater than 0, when the value of a is equal to 0. So here's the solution. Letter A. Since the value of f of a exists, so since the value of a is equal to 0, and negative 1 is when x is equal to 0, which means that f of a is equal to negative 1. Letter B. Does the limit of f of x as x approaches a exist? Let's find first the right-sided limit of this function. Limit 2 minus x squared when x approaches 0 from the right. Just substitute the value of a, which is 0, to this equation. 2 minus 0 squared, which only means that the value of our right-sided limit is 2. So next is the left-sided limit. Limit x plus 2 when x approaches 0 from the left. So again, just substitute the value of a to the equation, which is 0 plus 2, which means that the answer is also 2. So the left-sided limit is equal to the right-sided limit, or 2 is equal to 2, which only means that it satisfies the second condition. Letter C, or the last condition, is the limit of f of x as x approaches a is equal to the value of f of a. Since you get the value of f of a, which is equal to negative 1, and the limit of f of x is equal to 2, it means that they are not equal. So it does not satisfy the third condition. So this function is a removable type of discontinuity. Second example, f of x is equal to x squared minus 25 when x is less than negative 5, and square root of 25 minus x squared when x is greater than or equal negative 5 and less than or equal 5, and 5 minus x when x is greater than 5, when the value of a is equal to negative 5 and 5. So here's the solution. Letter A. Is the value of f of a exist? F of x is equal to square root of 25 minus x squared when x is equal to 5. We substitute the value of x to x, which results to f of 5 is equal to square root of 25 minus 5 squared, or f of 5 is equal to square root of 25 minus 25, or f of 5 is equal to square root of 0, which results to 0. So the value of f of a is equal to 0, which means that it satisfies the first condition. Letter B. Does the limit of f of x as x approaches a exist? So again, let's find first the right-sided limit of this function. Limit of x squared minus 25 when as x approaches negative 5 from the left when x is equal to negative 5. So again, just substitute the value. Negative 5 squared is equal to 25 or equal to 0. So the next thing to find is the left-sided limit. Limit of 5 minus x as x approaches 5 from the right is equal to 5 minus 5 is equal to 0. So since the value of our left-sided limit and right-sided limit is both 0, it only means that it satisfies the second condition. Letter C, or the last condition. Does the limit of f of x as x approaches a is equal to the value of f of a? So the value of f of a is 0, and the value of limit of f of x as x approaches a is 0 also, which means that the value of limit of f of x as x approaches a is equal to the value of f of a. So it satisfies the last condition. So this function satisfies the first, the second, and the last conditions, which means that this example or this function is continuous.
Thank you for watching. Please like and subscribe to my channel. See you on my next journey.